What I hope to do in this video is to just read a SAT reading comprehension passage with you. And when you're actually doing the SAT, you're obviously going to read it silently and you're going to try to read it quickly, but with good comprehension. But it might be useful to just read it out loud together, and I might just kind of think about how I think about the different things before I try to actually answer the question. So let's start. This passage is adapted from Young. Turtles use the Earth's magnetic field as global GPS. Written in 2011 by Kalmbach Publishing Company. All right, this is exciting. How do turtles use Earth's magnetic field as global GPS? And that's actually something I like to do. I like to convince myself that I'm very excited about what I'm about to learn. And in this case, I actually am. In 1996, a loggerhead turtle called Adelita swam across 9,000 miles from Mexico to Japan. That's impressive. Crossing the entire Pacific on her way. Wallace J. Nichols tracked this epic journey with a satellite tag. So they're using satellite tags to track it. But Adelita herself had no such technology at her disposal. How did she steer a route across 2 oceans to find her destination? So this seems like a pretty big question. How does a turtle with no GPS, without any navigation devices, go across 9,000 miles from Mexico to Japan? This is interesting. Nathan Putnam has the answer. Well, that's good. Someone does. By testing hatchling turtles in a special tank, he has found that they can use the Earth's magnetic field. So they're using the Earth's magnetic field as their own global positioning system. Wow. So they're using the Earth's magnetic field as their own GPS. By sensing the field, they can work out both their latitude and longitude and head in the right direction. That's amazing. Putnam works in the lab of Ken Lohman, who has been studying the magnetic abilities of loggerheads for over 20 years. In his lab at the University of North Carolina, Lohman places hatchlings in a large water tank surrounded by a large grid of electromagnetic coils. In 1991, he found that babies started swimming in the opposite direction if he used the coils to reverse the direction of the magnetic field around them. This is impressive. So this is how they were able to tell that the turtles use the magnetic field as a way to tell what direction to go to. Because if they reverse the magnetic field, then the turtles swam in the opposite direction. They could use the field as a compass to get their bearing. Let's keep going. I actually am interested in this. Later, Lohman showed that they can also use the magnetic field to work out their position. So not just the direction, but they can also work out their position. For them, this is literally a matter of life and death. Yeah, if they go to the wrong place, they might die. Hatchlings born off the coast of Florida spend their early lives in the North Atlantic Gyre, a warm current that circles between North America and Africa. If they're swept towards the cold waters outside the gyre, I actually haven't heard gyre, they die. Their magnetic sense keeps them safe. So if they go a little bit off track into the cold waters, they'll die outside of the gyre. Using this coil-surrounded tank, Lohman could mimic the magnetic field at different parts of the Earth's surface. If he simulated the field at the northern edge of the gyre, the hatchling swam southwards. Yeah, they don't want to go into that cold water. If he simulated the field at the gyre's southern edge, the turtle swam west-northwest. These experiments showed that the turtles can use their magnetic sense to work out their latitude, their position on a north-south axis. So they could work out their latitude, their position on a north-south axis. If they had the magnetic field at the south end of the gyre, they go north-northwest. If they're at the north end of the gyre, they go south. They don't want to get out of that thing because then I guess the water's going to be too cold. So that's how they can figure out how north or south they are. Now, where is my mouse? There it is. Now, Putnam has shown that they can also determine their longitude, their position on an east-west axis. Well, how do they do that? He tweaked the magnetic tanks to simulate the fields in 2 positions with the same latitude. So the same latitude is how far north-south, at opposite ends of the Atlantic. If the field simulated the West Atlantic near Puerto Rico, the turtles swam northeast. If the field matched that on the East Atlantic near the Cape Verde Islands, the turtle swam southwest. In the wild, both headings would keep them within the safe, warm embrace of the North Atlantic gyre. This is amazing. Before now, we knew that several animal migrants, so animals that travel, from loggerheads to reed warblers to sparrows, had some way of working out longitude. So longitude is how east-west you are. But no one knew how. By keeping the turtles in the same conditions, with only the magnetic fields around them changing, Putnam clearly showed that they can use fields to find their way. So this is the crux of what they're doing. By keeping the turtles in the same conditions, with only the magnetic fields around them changing, Putnam clearly showed that they can use these fields to find their way. In the wild, they might well also use other landmarks like the position of the sea, sun, and stars. Putnam thinks that the turtles work out their position using two features of the Earth's magnetic field that change over its surface. They can sense the field's inclination, or the angle at which it dips towards the surface. At the poles, this angle is roughly 90 degrees. And if you imagine this is the Earth right over here, and if the magnetic field is doing like this is what they're saying. Listen, the magnetic field is doing like this. The magnetic field is looking like this. I'll just keep drawing it. So they're saying at the poles, this angle is roughly 90 degrees. So at the poles, this angle is 90 degrees. And at the equator, it's roughly 0 degrees. You see it right over here. The field lines are parallel to the surface of the Earth at the equator, while they're going into the surface of the Earth at the poles. All right. They can also sense its intensity, which is strongest near the poles and weakest near the equator. Different parts of the world have unique combinations of these two variables. Different parts of the world have unique combinations of these two variables. Neither corresponds directly to either latitude or longitude, but together they provide a magnetic signature that tells the turtle where it is. This is fascinating. So what is, we have some diagrams right over here. This says orientation, and it's hard to read. It says orientation of hatchling loggerheads tested in magnetic fields. So West Atlantic, this is their orientation. The East Atlantic, this is their orientation. And then they have a description. Orientation of hatchling loggerheads tested in a magnetic field that simulates a position at the west side of the Atlantic near Puerto Rico on the left, so that's that one, and a position at the east side of the Atlantic near Cape Verde Islands on the right. The arrow in each circle indicates the mean direction that the group of hatchlings swam. So they do the mean, because they might not all swim in the exact direction. So the mean gives us kind of the central tendency. Data are plotted relative to geographic north, which would be 0 degrees. And you see, where on their east side, near Africa, they're going to swim away from that to, it looks like, to the southwest. And then when they are on the west side, when they're on the west side, they swim away from that. So they swim to the northeast, just like that. So this is fascinating. So that's us reading the passage. And obviously I read it much slower and out loud, which you wouldn't typically do when you're taking a standardized test. But I think we understood what's going on there. They were able to establish that these, is a big question. How are these turtles able to go 9,000 miles without a GPS device? And they were able to test, and hey, they had the hypothesis, hey, maybe it's the Earth's magnetic field, that they can sense how it's different in different parts of the Earth. And then they were able to test that by simulating Earth's magnetic field at different points of the Earth and seeing what the turtles did. And the turtles did what you would expect them to do. They behaved in ways that would keep them in the right direction as they migrate. So now that we, I think, have really digested the article, let's see if we can answer the questions. And I actually haven't seen these questions yet. I like to do this as fresh as possible so it simulates what you might go through when you're going to take a test.